I sure did forget to hit record. There it is. Okay, and then G, T, A, and then T, C, C, and the last three are going to be G, C, C. And of course, if we started at a 5 prime, we're going to end at a what? If we start at 5, we'll end at 3. Okay, so if we start at 5, we end at a 3 prime. Okay, so that's on that side. Now we know that DNA is double-stranded. Okay, so we've got to go ahead and write the complement on the other side. So using the same color pen, go back up to the other side and write the complements. Do that now. Guys, today is one of those days where you just really got to put your cell phones away and focus, because you're going to miss stuff. So make sure that you are really focused today. Okay, you should be writing the complements to those nitrogen bases. Remember the base pairing rule. You see a T, you put an A. You see an A, you put a T. See a G, you write a C. You see a C, you write a G. Okay, so looking on this side, if I have a 5 over here, what should I have over here? What's over here? If I've got 5 prime here, I should have a what there? A 3 prime. Good. All right, so TAC, what is the complement to that? ATG. GCC, what is the complement to that? Good. TAT, what is the complement to that? CAA, what is the complement to that? GTA, the complement is TCC, the complement is GCC, the complement is, and then we're going to end with the what? 5 prime. Okay? One side of DNA goes from 5 to 3. In other words, the 5 carbon on the sugar is pointing up here. Okay? And then the 3 prime is pointing down there. Opposite is true here. So it's almost like DNA goes in this direction on this side and the opposite direction on the other. All right. That being said, when we replicate, first things first, helicase has to unwind and unzip. So let's do that. We're just going to pull that out just like that. Helicase has now unwound and unzipped DNA. Come on, you're going to have to stay with me. Today's just one of those days. You have to stay with me. Now find the other color pen that you're using. I'm going to use red, whatever color makes you happy. Now, after helicase unwinds and unzips, the second step is that we have another enzyme called DNA polymerase. Polymerase is what it sounds like. DNA polymerase. DNA polymerase is now going to start adding the complements. Now, DNA polymerase is going to work in this direction, going on this side, and then it's going to work in this direction, going on that side. Okay? So let's all pretend to be DNA polymerase and start adding the complement. So for TAC, the complement is what? ATG. For GCC, the complement is what? CGG. For TAT, the complement is ATA. For CCA, the complement is GGT. For GTA, the complement is CAT. For TCC, the complement is AGG. And then for GCC, the complement is good. All right, now we're going to go on this side, and we're going to go in the opposite direction on this side. So GGC, the complement is CCG. For GGA, the complement is CCT. For TAC, the complement is ATG. All right, and then for TGG, the complement is, I hear one person. For ATA, the complement is TAT. For GGC, the complement is And for GTA, the complement is. Now let's talk primes. So over here, I've got a 5 prime. So over here, I've got to have a 3 prime. And so over here, I've got a 3 prime. So over here, I've got to have a. Okay, now on this side, I've got a 5 on this side. So this must be a. Bless you. Over here, I've got a 3 on this side. So this must be a. Good. Bear in mind that DNA, when copied, when we're all said and done, so we've got 2 new copies here of DNA. Great. Remember that really only half of it is new and the other half is old. Do you guys remember what that was called? It was at the very end of our notes last class. What is that called when half of DNA is old and the other half is new? Definitely on your test. Yes, sir. Say it one more time. Starts with an S. Semi-conservative. Yes, semi-conservative. Half of it is old, half of it is new. Also, we said earlier that half of DNA goes in one direction, 5 to 3, and the other half goes from 3 to 5. It almost looks like this side is right side up and this side is upside down. What do we call that? Well, one side of DNA kind of goes in one direction, the other side goes in the other. What is that called? Starts with an A. It was in your DNA structure notes. It's right in the middle. This is Mrs. Johnson. I do. I will. Thank you. Bye. What did you guys say? Anti-parallel. Very good. All right, so on the side here, we're going to go ahead and write the rules for DNA replication, or the 2 steps, really. It's only 2. DNA replication, you guys are going to definitely have to listen to me because you guys know that my handwriting is from the devil. Step 1, helicase, which is an enzyme, and it's an enzyme, so what type of macromolecule is it? A protein. Good. We got that right this time. Helicase unwinds and unzips DNA. So it breaks those hydrogen bonds. By the way, between A and T, how many hydrogen bonds are there? 2. And between G and C, there are? Excellent. So helicase unwinds and unzips DNA. Unwinds, that's a W. Unwinds and unzips DNA. Helicase unwinds and unzips DNA. Then, the really big word that you guys don't like saying, DNA polymerase. Polymerase. I know, a lot of syllables, that's okay. DNA polymerase adds the complementary bases. So, DNA polymerase adds the A's to the T's and the G's to the C's, and then we are done. I'm hoping that maybe this kind of helps you understand it a little bit better, because now we have to move on to kind of more difficult to understand stuff. We're moving on from DNA replication to protein synthesis. And when I say protein synthesis, synthesis means to make. So guess what we're going to make? Protein. Awesome. Okay, so I'm going to go ahead and end this recording. And I will post it. Those of you at home, can you see the pictures that I put in the chat?